going to talk about what's new in Autodesk CFD 2017. As everybody might know, we've launched the product just in this last week or so. And kind of the agenda that I'll talk about from just overall is I'll stay in PowerPoint for these first 3 bullet points, then I'll do live demonstration of a lot of these items I'll talk about, and then we'll end up with what the business model transformation means for us. I love my template. It didn't put my first and last name in there, but my name is Heath Houghton, and I am the product manager for Autodesk CFD, which means I set the development directives for our development team on where we go and what we put into the product. So solver technology is the first topic. What is new when it comes to solving? I thought we got an airplane.
Sorry.
No problem. Turn off that coffee brewer. No, anyway, what we put into the software from a solving technology standpoint is we added some new physics and we augmented our scalable solver, affectionately called CFD2, and we changed the workflow for it as well. So what do we do? We added hydrostatic pressure. What does that mean? This image you're seeing is a pretty good depiction of what we're talking about. So obviously, the further down in depth you go for dense fluids, so mostly used water, you'll have a higher pressure, and therefore this is a vertical manifold. In past versions of our software, if you just wanted to let gravity take effect and actually have the distribution be done properly, you would have to enable basically free surface, and that would enable the hydrostatic pressure option. We realize that a lot of times, though, you want to be able to simulate these things, and the actual height of the fluid isn't really changing, but you want to get the distribution properly. So going full-blown free surface is pretty much a waste of computational effort in those cases. So we added hydrostatic pressure as for our steady-state analyses without having to enable the volume of fluid approach. It's just a simple checkbox right next to where gravity is on the solver dialog, so it's easy to enable. So that's something we added. We also augmented our heat exchanger devices. The idealization for a heat exchanger to date was to be able to basically control, change air temperature as it flowed through the device, and in a number of ways. It could be thermostatically driven. It could be adding or removing heat. It could be a traditional, you enter in information for heat exchange between 2 fluids, and it would take care of that and do the temperature change of the fluid as it pass through. Well, we added the ability for it to track scalar, which means humidity. It can track humidity now. And not only that, but we added the ability to specify how it could alter that humidity. So it could become a steam humidifier. It could become a regular dehumidifier, adiabatic humidification, and I think there's one more to go through the list when we show the live demonstration. But basically, anything you could do from a commercial humidification or dehumidification, it now has that capability as well. So what does that mean for customers? It means that we're now becoming more and more physics capable for the complete set of what you might have when it comes to thermal comfort in your AEC environment, your built environment. There's more applications than that, but that I see as one of our biggest benefits to the customer. For Scalable Solver, we made it available last year as a flag-driven option. So I anticipated that the adoption rate might be quite low, and I think that's what we had seen in questionnaires and user studies. We've added more physics, and we've also made it a default option when you go to hit solve. So what is the Scalable Solver? It just means that the current solver right now is actually really fast, really takes care of your resources, but after about 16 cores on a machine, there's a significant drop-off in the performance or the benefit gain from additional cores. And I'm talking about physical cores here. So see, the current solver or the historical solver is really good up to that point. But if you have a high-powered machine, maybe it's not everybody has this, but 32-core machine, maybe a 64-core machine. your added benefit from getting that hardware was really limited. And the Scalable solver, up to hundreds of cores, solves very linearly, which means that there's no drop off in performance and speed up. So you're actually taking advantage of that. The physics set has been augmented this year. In addition to it, add variable material properties, some advanced turbulence models, so K omega SST and K omega SST SAS is also added. And we added scalar mixing, transient. So there's a lot of additional physics that are available for the user to be able to take advantage of if they have the hardware.
Hey, Heath, can I throw in a quick comment?
Yes, sir.
So you had said you're talking about physical cores. Just to throw a little bit more onto that, that's stating that when hyperthreading is turned on, that kind of doubles the amount of cores that you see, but it's not actual physical cores. You're not changing anything for the hardware in the machine, and that's what we use. That's why it's a fairly common question that I'll get of how come the solver is only using 50% of my processing power, and it's actually using 100% of it, but the way that Windows bookmarks it, if you have hyperthreading turned on, then it says you're only using half, because it thinks there's more cores out there, but we're just using the physical ones.
Right, right. Yeah, it is a common question. I know there are knowledge articles on that.
Right. I just felt like I should say that since we said something in the conversation, might as well.
Absolutely. And one thing I should point out too is that the CFD2 implementation, or the Scalable solver implementation, is to your local machine currently. And we're working on how we should go about unlocking that for, networks of computers. We have the capability of how we would make it easy from a UI perspective and the user experience and business model perspective to do that. But as we're unlocking that, as we're working on that capability unlock, we're also working on more physical models as we move forward. On my roadmap, I'm not going to be shy about it. I'll just say it. We're probably going to start targeting to make it a more complete solver for the electronics cooling customers. So to enable the devices that are needed for electronics cooling, like compact thermal models, radiation, stuff like that.
Right.
But for today, we've actually added quite a bit of capability in this release, and by default, you can select it for your machine. Now, if you have an 8-core machine and you select CFD2 or the Scalable solver, you really won't see much of the speed up because 8 cores was being fully utilized by the current solver. But if you happen to have a 32-core machine or whatever, then you would start seeing, it would start outpacing the traditional solver pretty significantly. So I'll move forward from there. That's what we've added from a solving technology standpoint. One thing we also had introduced in 2016 was the ability to surface wrap a model for external flows. The way we did it in 2016, just to get the functionality out to users, we had basically a standalone application. We hadn't had the timing wasn't right to add it into an integrated workflow inside of the CFD core product. So we had to have an external add-in that would export a mesh for you that you could then re-import. And just by the way, I had to explain that. I should probably tell the user that it was very valuable, but the workflow was lacking, to say the least. So we knew that, but we want to be able to offer it for people that really needed that piece of functionality.
Right.
Moving forward, it's integrated. So you're not going to an external application. There's a full workflow and it still is external flow only, but the integration there is so much improved. The workflow is drastically better, and there is new pieces of technology under the hood that make your end result, your final mesh, much better. We're actually using our auto sizing technology, so you don't have to learn 2 different types of meshing techniques necessarily to get a mesh on a service wrap model. And opening those models again, because the workflow is so quick in comparison, you're not importing in some kind of an external mesh. So the whole workflow is good. I'll show that later in the presentation. I'll show that live, what I mean by an improved workflow. Oh, one thing else, I'll go back to this slide. One thing else, just from a business standpoint for users, for all all of our customers is that if you were a Pro E customer in the past, or an NX customer, for instance, if you wanted to be able to utilize the launcher from NX or Pro E, you had to pay an additional line item for an additional, as a maybe IT professional or whatever. Maybe you didn't get involved as an end customer, as the user of the software, but your company would have to pay an extra little bit to help offset our royalties in order to provide that functionality. We've been working behind the scenes to eliminate royalty needs, basically augmenting our ability with our Autodesk translator functionality, basically to lower the cost, the price of point of entry, regardless of CAD system. So now there are no of these CAD connector SKUs needed moving forward for our customers. We've actually eliminated that extra piece you need in your license file, eliminated that extra little bit you might have to pay in order to use one of those 3 CAD softwares I listed, and so now nobody has to pay any kind of an extra fee no matter what their CAD platform is.
Or generate that portion of the license. That is huge.
Or generate that portion of the license. So yes, there are listening file. I know.
So annoying. It's so annoying.
So we are trying to consolidate and make everything easier. Hopefully people are seeing that as we move forward. We also, last year I stated that we had implemented a new UI engine. So our graphics engine under the hood was completely new last year. And so the performance was highly augmented last year. I mean, the frame rate, that's mostly what I would talk about was, you could have hundreds of traces, transparency everywhere, huge models, and your frame rate, your navigation of the model, the pan, zoom, and rotate was just no lag, right? And so what I'd also say at that point is we'll start investigating new results workflows that take advantage of this performance. And we did that this year. We added the ISO volume. The workflow is very similar to an ISO surface. We had to deprecate in 2016, if anybody's ever used the filter capability, just the graphics engine didn't have that same exact functionality. So we had to deprecate that, which means we had to eliminate it. Not many people used it because the performance was, quite honestly, not very good. It would really take a long time to do the filter. Well, now you have an ISO volume that is very snappy. It takes care of that filtering capability and adds more functionality as well. And so it's another way to visualize 3D flow, temperature results, what have you, that's important to you. And instead of just an ISO service with the ISO volume, it's a whole range. You can even take advantage of using those ranges and transparency to make what I would call a simplified workflow or a simplified version of volume rendering. So this is a simple image of a cyclone, seeing that 3D flow. You have the core and the other flow going around the core of that cyclone. We also redesigned particle traces from the ground up. I think from a user standpoint, this is going to be highly, it's already been highly well received by internal technical staff, people who use the software day in and day out. The redesign of the particle traces was from the ground up on how you add traces, manipulate them, where you even discover them in the software as a new user. So I'll talk about that here as we go forward. I'll be doing a demonstration on these results quantities. In addition, periodically over time, we've had requests for certain custom or one-off result types that we don't offer in the software by default. So in the software, we offer standard results quantities, and then you can supplement that with the results dialog and offer more types of results, thermal comfort, things that may not be on by default. But there's still requests for things that are, maybe there's some kind of a custom sanitation request where it's residence time times the scalar quantity, so the concentration, and that's how I disinfect a fluid volume. So it's things like that that you just can't anticipate, and or you can't just anticipate them all. Maybe it's a custom thermal comfort quantity, maybe it's wind chill, maybe it's something else that we don't offer. Well, we have the ability now for any of the variables, so the quantities that we actually solve for and display in the UI, the ability to use those to make a custom result. Maybe it's combining velocity and temperature, like I said, to do some kind of an additional thermal comfort. Maybe it's with humidity. Maybe it's, with your pressure times. Maybe there's a momentum number that you have that's related to the mass flow and some other quantity. We have the ability to put those in, to save them, to manage them, to export those out with the share file if you want to share it to a coworker, for instance, and have it propagate. All those results can be displayed in the results. I'll go through a demonstration. And in addition, not only in the results, but in the decision center. So if you see it in results, you can see it in the decision center, which is really nice, and it can be for customer quantities. I'll go through a demonstration of that as well. A large focus for us every year, I think, at least and under my tenure, has been to really look at the customer requests, see what the core of the need is. Maybe not give the exact feature that's been requested, but look at the theme. What are we trying to accomplish as a user of the software, as a customer? And so we have like what we call a UX top 10, and we try to single out what are some things we should really concentrate on to really help users out. So these are just a few. There are a lot of items, and I'll try to hit them as I go through the live demo, because there are a lot of things we augmented that are based off of the idea station, off of the forums, and off of just support cases where we see a trend. So one of the things is I need to visualize the size of my model and the orientation of my model, and I don't want to have this triad going through the center of my model and kind of obscuring my view. So okay, we added a ruler that scales with the model. We added the ability to have a coordinate triad and the ability to break it out. I want it on top of the model, I want it on the corner. I just want to see X, Y, Z coordinates versus actual bounding box domain sizes and stuff like that. We added that ability. One of the other things that we had seen as a theme was cloning control. Cloning is highly useful, but for large design studies, for instance, where you have multiple scenarios in a design, you want to clone that design, but you don't necessarily want to clone all the scenarios in the design. There was no affordance to only clone certain scenarios within a design. When you clone, you had to clone them all, delete the ones you didn't like, all that kind of stuff. So it was a little bit of there was improvement to be made in that workflow, even though it's highly useful. And in addition, we were also, when we did the clone from a bulk standpoint, including the mesh and results. Well, if you're actually changing the design, you might not need the mesh and results. You just want to start from the template. And so the ability to not have that bulk by default. So your cloning operations are faster, more customizable, all of that.
Heath, do you need to activate design or scenario to clone it?
I don't think so. No.
I was going to say, I think I did that inadvertently, because I always try and it never works. And I think it actually worked in 2017, and I didn't even think about it until now.
Yeah, I honestly haven't thought about it myself. I have to go back and test it out. You asked that question. So the whole epic of that, when we say epic, a large theme, that whole theme of what we're working on was really look at what people are struggling with or have thought, man, I really don't like the way that works exactly, and just augment the current functionality to really meet the expectation, right? And so I think, I'm not 100% sure if you have to actually change to the design in order to clone it, but I think we addressed it. So I'll test it out, and we'll have to answer that later. Maybe while we're in the Q&A. We can
I was going to say, when we do the demo, let's verify that.
Yeah, for sure. One of the other things we did as well from a visibility standpoint is the results objects. Currently, the way you kind of work, or in 2016 and previous versions, is if you wanted to hide an object, you typically had to go into that workflow that you typically be doing to edit the object. So if you wanted to hide a plane, you go in and open up a little separate dialog, dive in, hide the things, get out of the dialog. If you want to go hide an isometric surface, you go into that workflow. Now, all of those items are completely editable in the design study bar. So on the left-hand side, your feature tree-like objects. And that includes hiding, unhiding, changing their values, editing them real quick, not having to go through the ribbon if you don't want to. So if you're a customer that likes to use the design study bar for setup, you can do the exact same workflow for results viz and not have to ever go to the toolbar if you don't want. And there's a lot. I'll show you the speed of going through and hiding and unhiding and people were typically deleting things. Now there's no need to start deleting things. The way this workflow works is much improved. So my next topics are subscription options and what the business model transformation is. I'm going to hold off on that and do some live demonstration of what I've talked about from a software standpoint. Oh, here's all my notifications on meetings. Okay. So the first thing that I will start on is the workflow for surface wrapping, because I'm going to do some live operations. I'll need to cut away from it while I'm talking about other things as it does some calculations. I like to do completely live and non-canned if I can when we're doing these demonstrations. So
only guy I know that doesn't rely on the smoke and mirrors.
Yeah. And if it crashes, which it shouldn't, that's just proof, right? So no, that's a joke about live demos. You can never anticipate what might happen. But so here's the deal. I'm going to create a new design study. And one of the things I want you to realize with new design study, I need to go to a different place on my hard drive. So look at the CAD types that we can import in. Now, we still have the ability to import in all the regular CAD types, but there's a lot of surface-based CAD, like SketchUp, OBJ, STL, all those types of files we couldn't even come into CFD at all with in the past. Now you can, but again, they're surface-based, so they're not solid geometry. The only way to bring them in is to surface wrap them to turn them into proper geometry. But we actually have the affordance to do that now, right? Before it was a standalone application, and you could load those into your standalone application, create a mesh based off of surface wrapping workflows, but totally foreign environment. So it's a little bit of a learning curve. So now let's say I want to bring in an STL file. So I have this little submarine here. It's actually a pretty large STL file. It's very uniform on the size or the size of the polygon count, I guess I should say. So one of the things you should notice is before we had like a little checkbox for taking it to diagnostics versus starting a design study without going through the diagnostic check or the model assessment toolkit. So now what we have is the same two things, but again, we're some logic here. I don't want to do model diagnostics because I really just need to service wrap this guy. And so I'm going to bring that into the service wrap environment. This is 105 megabyte STL with tons of polys on it, and we'll bring that into the environment. It'll take about a minute to open that sucker up, maybe about 30 seconds. So again, this is live, no tricks, no mirrors. I just go with it. I won't even turn on the visual style because it would look all black. There's so many polys on this. So just suffice to say, it's very, very dense. And you can probably tell if I don't turn on you can see the kind of the check ring if your resolution on your screen is nice. But this model, the reason it needs wrapping, besides being a format that's surface-based, is that we have gaps. This wing piece actually goes through the model, and I don't know if it shows up if I go transparent or not. Yeah, so it goes through the model, and there's a lot of little things on the inside. So it's not a real great model. I have to do some manipulation on it. Well, it's an STL file. I can't really manipulate STL files very well. We have some tools for that, but it could be a lot of time and effort. And really, this is a submarine or a submersible vehicle, or it's a car, or it's external wind wake studies on a city block. Those type of studies, I can service wrap that and not have to worry about all the CAD work that's done, all the CAD prep to get the simulation ready. One thing I want you to notice as I'm going through the interface on this is that here's the ruler. As I zoom in and out, it's dynamically changing to give me an idea of scale as I maybe inspect things on the model. In addition, I have my triad, my coordinate, origin, and I have this. Well, in our standpoint, you don't have to have them all on. You have whichever one you want on. I usually just like to have a little triad in the corner. So that's user request, is to add scale, add the ability to always see where X, Y, and Z are without obscuring my model view. Those are things that have been asked for, so we provide them this year. Okay, going back to our surface wrap workflow, it's actually much simplified compared to the other and there's additional functionality. So compared to that standalone application, I need an external volume on this. I click on external volume. Pretty simple, straightforward. So here, you'll notice a box is automatically made around this model. How did that happen? Well, we have what we call an auto sizing on it. Instead of, there's drag handles and I can grab them and manipulate. But if I want to be consistent from design to design, I probably am using a very similar model. If it's an AEC model where I'm a city block or a building with a few buildings around it, or if I'm doing a car, I kind of have a general guideline on what does the fluid domain need to be around that to give me a proper simulation. So in this case, I can have that, and it saves as a default and happens automatically every time, and then I can just change it if I want. So in this case, I have a bounding box that goes around this thing, certain defaults. If I want to change the number, let's say I want it to, for this case, not intersect with the bottom of my submersible here, I can change that, hit auto size. Now my box has changed to a certain size. Again, I can manipulate that with these grab handles and everything around, but I found it easier just to hit this auto size when I have a proper basis. And I probably didn't explain that very well because I'm trying to rush through things, but 6x the model in that dimension, 3x the model in that dimension. So it's actually calculating based off of the size of the model. It's a very consistent workflow. You're not telling it the actual size of the box, you're telling it in relation to your model. You can also snap to the ends of the different directions. Not going to go through that right now, but that's setting that external volume so that there's additional functionality there. I want to wrap it. Pretty simple workflow. I just tell it how big the resolution factor is. So what this means, one number to tell how fine of a wrap I want on it. So the more to the right, the longer it'll take the wrap, the more detail will be captured. The more to the left, the larger features that will get paved over with the wrap, and the faster it will go. So it'll be more blocky of a shape. So I'll just go with the defaults here. And then the next step would be to generate the wrap. I'll go ahead and do that. This is going to take it about 2 or 3 minutes. I could sit here and fill the time with a joke or whatever, but I'm terrible at that. So I'm going to go ahead and start looking at other workflows, and we'll come back to what does the wrap look like, and what does the workflow look like from there when we go into CFD. So I'm going to go ahead and skip around a little bit. So let's talk about ISO volumes and traces. And I'll go ahead and a little bit of the UX work that we put into into the software. So like I said earlier, traces are no longer constrained to planes. They're their own entity. They're not constrained to planes. They can be seated on planes, but they don't have to be. And we've totally worked that from the ground up. And we've worked the workflow on, if you have results types, entities I call them, those planes, traces, ISO volumes, ISO surfaces, I can actually hide them, manipulate them, get through their editing environment pretty quickly while I just do the design study bar. So I just hid those traces. I didn't have to delete them. I didn't have to go to some separate menu, some sub-menu to get to them. It's more attainable. So let's look at, from a software standpoint, let's look at the ISO volume. I want to unclutter the environment real quick before I did that. Let's look at an ISO volume. What does that mean? So if you're familiar with ISO surfaces, it's a very similar concept where you had one slider bar and you control the quantity and what you're coloring it by. Now you have two, so you have a range. So before, if I were to actually just take the slider bar and go like that, technically that's an ISO surface. You're looking at one value, but now I can look at the range. So where's everything warmer and colder in this model? I can start to augment my look. And in this case, I'm going to do velocity. So a range of velocity, higher velocity to lower velocity. The benefit here is not every model will you see a huge difference between what an ISO surface would have looked like and an ISO volume, but in this case you would. So I'm not going all the way to zero velocity here, which means that I would have had, or let's say I do go to zero velocity. So, well, not a good idea. All of this is covered up with zero velocity.
Right. All your wetted surfaces are going to be zero.
Yeah, so. But in this case, what you would see from an ISO surface standpoint is this is a wetted surface right here. It's touching the housing. So I would actually be seeing through the ISO volume. It's an aesthetic thing to me, but I like to have it as a fully enclosed volume. It's visually more appealing to me. but there are cases where this range of flow, so if I were to color everything by velocity here, I have my high velocity taken care of. Anything from 1 to 7 meters per second is all shown, instead of having to have multiple ISO surfaces to try to get to the same point. And as in everything else, we can make it transparent. We do what we want. So I don't want to have the highest velocity. If I want to see, kind of take out some of that core stuff, I can move this over and get rid of pieces, so I can start to see the differentiation between where is it 1 to 2. So now I'm starting to see where anything inside of this little orange spot is 2, and I can have multiple of these, so I can start changing the transparency levels, really working for what I would call almost like a volume render effect. Okay, that is that. I don't want to belabor that too much because I have so much to cover in live demonstration mode, and we have not a ton of time today. Traces. So I turn on those traces, turn them off. I'm going to go ahead, just double check and see how long it was taken before I go on. For traces, again, it's a top level quantity now, so it's not tied to the planes. The seeding types are different. So I can see the point. I can see the line, a ring of traces. I can do a circular pattern, a rectangular pattern, region. I'll go through all of these as quickly as I can. I'm going to change my visual style. One of the things I didn't actually kind of detail out to everybody is we added this material-based visualization for both setup and for results, where all the solids become solid and the fluids become transparent. So I just unhid the fluids, and you can see that the fluids are transparent. It's actually really helpful for setup to have that workflow. And then here, and when you're coming into looking at the results, to then potentially have this in transparent to understand what your fluid domain is, but then, just like we can previously go through and say, hey, for all the air action, I'm going to make that all in outline mode, or I'm going to hide it. So in this case, I'm actually going to hide these guys. That way, I'm not getting in the way of the rest of my demonstration. So I'm going to go to traces, look at adding. First of all, I'll show you how you can add a point. So remember, they're not tied to planes anymore. Click add first. Click on a point on the model. Click another point on the model. Another point on the model. If they're a plane, I can click on a plane. The first thing it sees that's non-outline mode, so it has some color shading to it, whether it be transparent or meshed or in shaded mode. It will actually put that point there. And actually, what's even cooler, even while I'm adding them, I can start manipulating where they're located, and we'll see dynamic updates of those traces as we do it. So it's much easier to see, I see it here, where's the flow coming and going, so this triad's manipulatable, and pan zoom and rotate that triad. So that was just a little demonstration on point. As a matter of fact, I'm not done adding. I could continue to add more points and manipulate that data set as I see fit. Just a really simple, easy way to manipulate the trace seeding for one aspect of it. So I'm going to go ahead and remove that trace set because I have so much more to show here. I can do a similar thing for line. Let's say I wanted to make a line of traces right across the inlet, and maybe not right at the inlet, maybe a little bit off of this heat sink. Pretty quick and easy to do that. Maybe I want to look at, well, as I change height, what does that do to the trace pattern, where they're coming from, where they're going. You can do that really dynamic. I guess the one thing I want to emphasize here is very dynamic seeding of your traces, and I'll continue to do a couple other demonstrations of what I mean by that. So traditionally, people might want a seeding of the traces that is very uniform at an inlet. So I'm going to actually shade this inlet here or make it transparent. And if I wanted to get an exact, real even distribution at this inlet, what did I have to do in the future? I'd do rectangular. I'd preset my grid. I would then try to grab it at exact locations. If I was a little bit off, I'd have to delete and start over. Since we're all dynamic here, and that's the theme, Let me go ahead and just add a grid. And that grid, by the way, can be diamond grid or hexagon. So I'll just go with just regular grid. That's what we're traditionally used to seeing. So got my grid here. And what if I don't like the seating? Well, I already hit OK. But let me start over. So the workflow would be, let me change that. As I'm dynamically going about, I'm not sure if that shows up real well. I might need to change my view orientation. There we go. As I start to select and make the sizing, if I don't like that grid size, I can just make it tighter or make it more sparse, and then finalize my trace set. But that even in and of itself, if I want a truly uniform and equally spaced, all from the periphery, there's an even better workflow that we've even introduced, and that is the ability to do region. Based off that grid spacing, I click on this inlet. Oops, let me hit add first. I click on this inlet, and automatically, boom, there's your seating, perfectly uniform at that inlet, or on that face. So I hit region, it's on a face in the model. Let me show you what I mean by that again. So let's say I wanted to add, for whatever reason, on the top of this cylinder, the region. Well, that grid spacing happens to be so sparse that it only did one. So that was a fail. I didn't preset my sizing. So I'll go ahead and make my sizing a lot more advanced. I'd add, click on that face. Now you can see a grid right off the top. I can still manipulate it. There's a seating of traces right over the top of that cylinder. So what if that were like a hot component that doesn't have a heat sink? I want to know how much airflow is going by it, temperature of the air, whatever. I quickly and easily saw where the air came from, where it's going over that component. Hopefully that makes sense to everybody. There's additional things I can do. So I just pulled this off of that surface. What if I wanted to actually, translate this to another face? We have this down to shaded surface, which will pop it down to the next shaded surface, and so I can see any number of ways and push this onto the opposite direction of this yellow arrow. It'll map down to whatever face, and it doesn't have to be planar like that, right? It can be some kind of curved surface. So there's the ability to see, like for aerodynamic flows, right off the face of a body, and be uniformly spaced off that face at that point, no matter its shape. Anyway, so these are all things I can do. If I have too many trace sets, don't like them, I'm going to go ahead and hide these trace sets. I have better seating than I did on the other ones. I'll unhide those. And let's just talk about manipulation of trace sets, right? So what can I do here that's easier than before? I have this set highlighted. I'm going to go ahead. By the way, I can hit edit over here, or like I was talking about, the workflow is, let me edit this trace set. Matter of fact, I could have changed the coloring right there within the right click menu. But here, before we had appearance was kind of buried a little bit, like 2 menus deep, and manipulation, it's all in one set here, or one dialog. And if I want to color the results of the trace by something other than the global result, I can do that. So right now I'm showing temperature on the solids and the geometry, the global results, but I'm showing velocity. I could show anything I want. I could show pressure, temperature, if I was doing mixing, do whatever I want for each individual trace set. It's a huge difference in what you could actually do in the past in the traces. Matter of fact, I don't even have to have a results quantity at all. I just color them up by color if I want to differentiate different trace sets and see if it's coming from one location to another. That's why it's coming from location 2. That's orange or whatever. I can do that to further differentiate what's going on.
Heath, fun fact for you: you could do that before, but I doubt there's many people that could tell you how.
100%. But and what you couldn't do from a result standpoint is say, well, this one's a velocity trace set, that's a pressure trace set, that's a temperature.
Oh yeah, for each set to change it, you definitely couldn't do that. But you could change the variable, but I'd put it at less than 100 people on the planet.
Right. And for an easy to use software, that's not a very good statement, right? So
right.
So the other thing is something that's different, and it's not going to show up very well here is, but I can change the range to full, or forward or backward. So I could go full backward. So these are offset from the inlet just a little bit. So I could just where did it come from. If I move this trace set again, it would show where it came from versus the just forward or the full range forward and backward. Couldn't do that in the past. You could only do full basically. And if you wanted to go just forward, you had to change it to a mass trace, and then go through all that workflow of specifying mass on the traces and all that, which we still have that workflow, but for introducing mass. But in addition, I want to quickly just change the size of these traces, maybe even make them real thin so it doesn't obscure based on the geometry. Make them really fat. That's going to look really thick to you guys, but really change quickly the way you're going to view the traces. As a matter of fact, I'm going forward only, right? So what if I only want to go forward a little bit? Before, you're buried in a dialog. So in order to do something like this, where I'm dynamically seeing, just without even animating, just where are the traces going? It may not come over in the web real well, but just pushing those traces forward to see where they progress. Something you couldn't do in the past. I think this is not going to come over the web too well because it's dynamically moving these traces, but it may just kind of jump.
Yeah.
But anyway, that's
delay.
Yeah, that's what you can do in the software real quick. And I want to leave about 5 or 10 minutes for question and answer, so I'm going to hurry up and talk about a couple of things from a solver and visualization and another model. So while I'm in results mode, let's go ahead and talk about some things we added. One of the things we added, and I'll just barely go across it, is heat exchanger. In the heat exchanger in the past, it didn't handle any kind of, if you turned on humidity and you had a heat exchanger, you wouldn't get, they weren't compatible. Now they're compatible, but more importantly, in the type of things they can handle is not only the 4 that were there before, heat input extraction, temperature change, heat exchanger, or air conditioning. You now have these humidification and dehumidification processes that could be part of the heat exchanger. So in this case, I have an adiabatic humidification, which basically is saying whatever the inlet comes in at, we have a flow rate for this device, and it's going to change, in this case, the relative humidity to exit at 60%. And since it's an adiabatic process, the temperature is going to drop. Users shouldn't specify that. It should be, we'll calculate it for how much is it going to drop in temperature. Other cases might be where, I have an enthalpy heat exchanger, and I'm actually going to specify what that exit temperature is and what the humidity is, either by specifying how much mass I'm adding via steam or whatever the relative or absolute humidity is at the exit. So there's basically any commercial use of humidification, dehumidification, we capture in these 4. There might be some fringe cases, but the vast majority of processes that you might have for humidification or dehumidification are in there. So that's enough of that. Nobody likes material editors. Let's get out of that. Let's look at the results. So I go into results. This is a model that I've shown in the past, and I've actually got some customer results showing here. So let me stop showing that for just a second. On this plane, what we'll look at is look at velocity real quick. So again, here, easy to see my my humidifier device, and I might even just change the scale on so it's easier to see where the high velocity is. So in this model, I have high velocity coming out of there. I want to look at on the plane. Come on, Heath. Getting nervous, guys. I want to look at the relative humidity. I can do that. So in this space, the relative humidity started out at, 20% or something, and then we're having humid air come in at 30% from the vent. But this device is actually has a certain flow rate and offering the humidity back into the space at 60%. It's adding that much humidity. One thing I want to point out, if I hover over this device, global, is we had specified quite a bit of information actually. Am I missing something? Need to hide a few things to get to my device. The tooltip should be showing up. Oh, I know what I did wrong. Okay, so from a tooltip standpoint, I should be seeing here in a second my device. Oh, I've got things in the way. When all else fails, change the way you look at things. Okay, so when if you look at the device, we're actually offering a lot of information about what's happening in order to enable that 60% exit humidity. So again, I specified 60% exit humidity. What is that in terms of absolute? What is the inlet that came into the device? What are the temperatures that happened? How much heat actually was removed or added due to in the sensible range and in the latent realm? How much mass of water would have to be added or removed to affect that humidity change? All of that information is sitting there, so you can size a commercial humidity device if you want. So that's just one thing. But what I really wanted to kind of get at again is that all the physics are taken care of. It's something that we just didn't have. By the way, I'm going to show this in a second, but we've added some stuff for mesh adaptation. I want to make another plug on that. Look how beautiful that jet is. I'll show that in results viz in here in a second and show that the mesh is not something I put in, but taken care of by mesh adaptation to put the proper amount of mesh in one adaptation cycle in order to capture that plume effectively without having to pre-know the answer or specify it. But let's take one more look at the results. I forgot about 5 minutes ago. So in this case, I've added the ability to look at humidity, look at velocity. I might have a specialized quantity that's not taken care of in our thermal comfort calculation. So what I would need to be able to do then in the past is write a script, export this plain results, do some manipulation in Excel or whatever, and then extract it in a graph. But I couldn't do interactive things with the custom result quantity unless I was really good at scripting, which I would say maybe there's 5 people in the world that can really do that on a CFD scale, even though it's Python. It's not like a lot of people that can do it. I can't. I'm not a Python expert myself. So what we would look at here is how can we make that more accessible to do these things? Well, we added the capability for custom result quantities. Basically, I can take a look at what are the variables that are available and then use them in combination and with other multipliers or whatever math functions to come up with my custom result that's important to me. So a couple of things here that I've added that are automated, that were saved by default to my available equations. One I want to look at, I just added this morning, was like a drop rating. So grab this straight from a website. And this is like notes to make sure I understand what the equation's all about. Persons that would say that they felt a draft is based on in units of Celsius and meters per second, certain temperature range, temperature values and turbulence. And long story short, here's the equation. So I just copied that equation, did a conversion to make sure I was in the proper units, and I can even test that ahead of time. So let's say the temperature was 25 Celsius and the velocity was 0.5 meters per second. I do a test. Did I do it right? I didn't do it right. Oops. Let me, oh, yeah, very, very wrong number. So if my number in inches per second, because that's what I have for velocity here, inch watts. So if I were to say, in whatever inches per second, then 17 at that temperature and that speed local, 17% would just, based on that equation, right, would say that I feel a draft. You want that to be as low a percentage as possible in a built environment. So you'd be able to then take this equation, look at it throughout the space. Where are people most likely to be seated, standing in occupancy, and let's see if they're going to say I felt the draft. So the plain result, I've got this drop rating. I can see it. So if they're right in front of the humidifier, obviously. They're standing right in front of the register, obviously. Person seated actually right here. Let me compare these results side by side a little bit. So change the value here, options. So drop rating on the left, velocity on the right, because it's kind of dominated by temperature and velocity. Let's look at velocity. It's a high velocity. So let me again change the view a little bit. Yeah, that's a pretty good number there. So we can see is there's higher velocity here. Obviously, your drop rating will be higher because according to that equation, the temperature difference between 34 and whatever the local temperature is and the local velocity. And here we have a little bit higher velocity, and I can see on this plane that 42% of the people, according to the scientific study, would say, or 45 in that spot, would say, I feel a draft. That's not a very good percentage. Probably want to change the airflow patterns in the room in order to not have that happen, right? So something you couldn't do in the past. You can make inference, but you wouldn't be able to visualize it and actually quantify it. And more importantly, you can do all the things we can do with results. So in this case, I want to do an XY plot. I want to say, well, in the seated area, kind of what's that look like for drop rating from here to here? Let's plot that. And so here's the drop rating. 40 kind of gets higher as you get further over along that line. You know, I could kind of surmise velocity and based on temperature. Temperature is pretty uniform in that area, so it's dominated by velocity. But if there were a large temperature gradient, we would see more of a difference between drop rating and just local velocity correlation. If we had something that was related to relative humidity, we could also make, you know, or related to the concentration of the water in the air. We could do a calculation based on that too. What's cool is though that these things become available in the summary. So if I click summary, go to the decision center, I can actually you know, plot these out. So I already have one. Look at that, drop rating for multiple designs. You can see it. By the way, I'm going to make another plug on something we did in the UX. Something we did was we added, before you had to right click if you want to add values to your display quantities for, let's say, summary points and stuff like that. Now, it's just hey, I'm going to go ahead and select all or none, add a few, so I'm going to hit none. I only want to look at velocity, temperature, drop rating, maybe a little bit of relative humidity on that plot or at that point. Go ahead and look at it. So a couple of them we didn't solve for relative humidity, so they didn't show up, but we can see all those values against each other. So in this case, if I look at the drop rating, plot it, real easy to get through there. Oh, you can get that one. Oh, it's all go small. I need to change the scale. Yeah, I just have to change the scale on that to look at it. But the ability is that we would be able to see all of the values that we want, not only pre-calculated quantities, but also your custom results, which is a huge benefit. Okay, man, I'm running along. So I think that covered the majority of results. I didn't finish my workflow for surface wrapping. So here's that surface wrap volume. Here it is with the wrap. So we had that gap that's been filled in, and this is the wrap. Now all we would do at this point is transfer this wrap to the setup, and we work with it like it's regular geometry. There's none of this, I need to learn a new meshing technique, bulky import. You see how fast I imported in? Now I just do normal setup. You know, I set up my air or water or whatever it is, and I go through the same workflow. From a meshing standpoint, I use my auto sizing that I'm used to and all of that. So it's a really cool workflow. As a matter of fact, I'm just going to quickly hit auto size on this. It'll happen pretty quickly. For these surface wrap models, we actually even added some new functionality. This is for surface wrap only, by the way. We added, as a test bed, in my mind, the ability to kind of look at, you know, what's the relative mesh density based on the auto sizing. So again, that's one element. I want to look at a collection of those elements to see the overall distribution. I want to look at a preview of what that mesh really looks like. You can see it right there. So 3 levels of preview, like these dots now represent relative mesh density. We can do the grid, show you like the size over specific regions of the model, or we can actually just fully preview like we could in regular models. But going really fast on that, but that's new workflow, right? So before, separate application, learning new mesh controls that are totally foreign and size-based and not our relative thing that we like to do with our auto sizing, and a bulky model. All that stuff should be taken care of now. None of the bulkiness, none of the workflow kind of weirdness. So I've covered a lot. I think I covered the majority of it. I'd be remiss if I did not cover what does the business model transformation mean in Autodesk for the offering. So previously we had Flex and we had Desktop, right? So what was that? It was perpetual and it was subscription. So Flex was a subscription product, it was a yearly thing. Desktop was perpetual. Now what we're doing is, and Flex was named user, 1 person per seat, that's it. It's the 1 person that gets it. What we've done is it's kind of a hybrid model now where it's subscription only. If you're going to buy a new seat after, you're going to buy a new seat after like, I think it's July 31st. You can only do subscription, but it's networked just like the desktop. So it's a networked version of the software, and it has cloud access as well. So it's kind of combining the 2 products. Forget the marketing stuff. We do think it provides greater value because you have the option to have a networked version of a cloud-enabled product. You have the ability to be on subscription, which means a lower cost point, to also have the ability to have a network product that is a lower cost point, and your access is really more flexible. We think it's a better overall experience. But basically, what does that mean for me if I need another seat? So you're going to have the ability as a customer or whoever your procurement workforce is, the ability to buy perpetual licenses up till July 31st. At that point, you can continue, and you can, by the way, you can always renew perpetual licenses if you want. You can stay on perpetual, which means you own the software, and stay on what would be good subscription or maintenance for those products. You can continue to do that. You also have the option before August 1st to just buy the subscription as it's offered in the newer way I just described it, which is it's a network subscription with the ability to hit the cloud. Once you hit August 1st, you can still renew your maintenance, but your only option to buy net new seats is to buy a subscription. From a software standpoint, what's it look like? I kind of neglected to say, when I get solved, what does that look like? It looks like this. I can solve on my computer. I can solve with my computer or a mobile computer. I can solve my computer for the Scalable solver if I have a workhorse machine that I'm on, or I can solve in the cloud. And it's all in the one product. There's no differentiation anymore between is this a cloud-enabled product or not. You don't have to solve in the cloud. You just have the option.
Which is really cool because I think that's a feature that a lot of people, at least from my side, people have asked about it because they've been longtime customers, but they didn't want to switch over to the cloud product.
Mm-hmm. Yeah.
So now they've got it. Pretty cool.
Yeah, and so let's say they're a longtime customer, but they want to stay on a perpetual maintenance basis, right?
Yep.
They can stay on perpetual, and they get this ability just by staying on. They don't have to switch over to a subscription pay model, right? They don't have to do the lease model. But if they want to, they can. They can switch over if they want. It's just their option. We're trying to get people an easy transition to whatever they want. So I will stop there.
Yeah, I was going to say we already ran over, and apologize for that, and appreciate everybody's time. Thanks for joining us, and if you have any questions, definitely reach out to support, and I can try and help anybody out. Heath, thank you very much for stepping in and presenting this for everybody. This is great.
Yeah, apologize for running over. A lot of material I do live, so there's no way to just flip through PowerPoint slides and get it done in a finite number of times sometimes, but appreciate everybody joining in, and I'm always available too. Yeah, appreciate you guys, and I'll talk to you later.